Hello everyone, the chemical and physical properties of kerosene are
Appearance: clear to straw-colored liquid. Odor: characteristic petroleum of kerosene-like odor. Odor threshold: -1 ppm typically report. pH not applicable. Melting point, freezing point. Heat point can be about -degrees Fahrenheit. Freezing requires laboratory conditions. Initial boiling point and range: 154-372 degrees Celsius. Flash point: 38 degrees Celsius. Evaporation rate: higher initially and declining as lighter components evaporate. Flammability: solid gas. Flammable vapor released by liquid. Upper explosive limit: 5%. Lower explosive limit: 7%. Vapor pressure: smaller than mmHg at 20 degrees Celsius. Vapor density: air equals 1, greater than 4.5. A G slash ml.
The kerosene is a polycyclic hydrocarbon. This has a long story. Around the 10th century, the Persian Al-Razi, a doctor, humanist, and also known as the father of the pediatrics, described in one of his many works was the distillation of the oil of illumination. However, it was until the 19th century that he was begun to give its importance. Petroleum byproducts have been used since ancient times as adhesive and waterproofing agents. Over 2000 years ago, Arabian scientists explored ways to distill petroleum into individual components that could be used for a specialist purpose. As new uses were discovered, demand for petroleum increased. Kerosene was discovered in 1853 by Abraham Jenner, a British physician. Jenner developed a process to extract the inflammable liquid from asphalt, a waxy petroleum mixture. The term kerosene is in fact derived from the Greek word from wax, sometimes spelled kerosene or kerosene. It is also called coal oil because of its and asphalt origin. Kerosene was an important commodity in the days before electric lighting, and it was the first material to be chemically extracted on a large commercial scale. Mass refinement of kerosene and other petroleum products actually began in the 1859, when the oil was discovered in the United States. An entire industry involved to develop oil, drilling, and purification techniques. Kerosene continued to be the most important refinery product throughout the late 1890s and early 1900s. It was surpassed by gasoline in 1920s, while the increasing popularity of the internal combustion engine. Others were found for kerosene after demands for oil lamps, and today it is primarily used in resident heating and as fuel additive. In the late 1990s, annual production had grown to approximately 1 billion well in the United States alone. Crude oil extraction methods kerosene is made by refining raw oil. Raw oil is refined by using a distillation process raw carbon atoms. When heated up different fraction of the oil vaporized at different temperatures dependent of the properties of the carbon chain. Consequently, different oil products or fractions can be distilled or separated from each other by heating oil since they have different boiling temperatures. Condensing the vapor will give the oil products in the liquid form. Light oil products are products where 90% of the content will vapors at temperatures up to 210 centigrades. Kerosene is a light oil product.
Now, I will tell you about reactivity profile.
Saturate aliphatic hydrocarbons contained in kerosene may be incompatible with strong oxidizing agents like nitric acid. Sharing of the hydrocarbon may occur following by ignition of unreacted hydrocarbon and other navy combustibles. In other settings, aliphatic saturate hydrocarbons are mostly unreacted. They are not affected by aqueous solutions of acids, alkalis, most oxidizing agents, and most reducing agents.
I will mention some applications of the kerosene.
Chemical properties. Kerosene uses have expanded beyond creating energy or burning it. As a derivative of petroleum, it has many of the same chemical properties. The chemical industry can use kerosene as a petroleum solvent or industry-grade chemical lubricant. It is also found in some pesticides and is particularly helpful in the elimination of the head lice. Lamps and lighting fuel. Kerosene is a very effective lighting fuel. Campers and those who live in rural areas love using kerosene lamps because of the longevity of the fuel and its ease of transportation. One type of kerosene lamp, called a hurricane lamp, was designed to be available during the worst conditions. Users can easily control the level of the flame with knobs that control the flow of the oxygen to the oil. Heating oil. Larger scale kerosene heaters are rare, but you can find portable kerosene room models. They are popular in areas where blackouts can be expected after a disaster. Kerosene room heaters do not require electricity to run, and some models can heat an area of up 1000 feet. Kerosene is a versatile heating oil which can be really controlled, so portable kerosene room heaters regulate room temperatures easily and safely. Jet engine fuel. In recent years, kerosene has developed another important use: jet fuel. It is highly combustible, making it suitable for the demands of a jet. However, it has a low vapor level, which means that it has a low chance of blow up. Fire entertainment. Circus performance, stage effects, and another live performance that include fire use kerosene because of its low fire temperature. It's a safer alternative than another surge of flames while offering an impressive show.